In this lesson, we're looking at key features of polynomial, radical, and trigonometric functions. This lesson is intended for geometry students who have taken Algebra 1 and Geometry already. This is an Algebra 2 Readines lesson. So I will just be giving an overview of polynomial, radical, and trigonometric functions. So let's go ahead and get started. The first type of function we're looking at is a polynomial function, and we have an example here of a graph of a polynomial function. As you can see, it has several curves. It crosses the x-axis several times. It crosses the y-axis also. And so we're going to just get into a little more reviewing these polynomial functions. For the first example here, we're looking at the application of zeros. It says the graph below models the rodent population, R of t, of a protected federal forest where t is the time in months since observations of that area began. And part A, it says what is the zero of the function? So remember, the zero of a graph is just where that graph crosses the x-axis. And so the zero of this function is x is equal to 8.42. That's right here. And we know that it's exactly 8.42 because we have the point right here as well. If we did not have that ordered pair there, we would just kind of estimate what the function, the zero would be. For B, it says, what does the zero mean in this context? Well, it is the number of months it took for the rodent populations to go away. So we have down here for our x values the months, and for our y values that's the number of rodents. But for x, it is the number of months that it took the rodent population to go away. Now let's take a look at the domain and relative minimum and maximum of this graph here. It says consider the graph of the polynomial function f of x is equal to negative 1/3 x times x minus 2 squared times x plus 1. And we want to identify the following key features. So first, we're identifying the domain. Remember, the domain is of a polynomial is a set, the entire set of real numbers, and so the domain would be from negative infinity to positive infinity if we're in an interval notation, or we could just say all real numbers. For B, we have the relative minimum, and so the minimum would be, or the relative minimum would be about here. All right, so the ordered pair would be 0.8, negative 0.8 right here, or y is approximately negative 0.8 right here. All right, the relative maximum, so minimum, the lowest point, maximum, highest, so it would be right here at these 2 points here. All right, and so that would be negative 0.55 approximately, and then 2, 0 right here. So those are the two highest points. D, it says an interval where the function is increasing, and so we read from left to right. So where is this function increasing from left to right? And so we can see that it's increasing right here as well as right here. And we're going to put our x values. So from negative infinity to negative 0.5, and so that is where it will stop increasing. And then 0.8 to 2, so right here, that is where it will stop increasing. All right, and then last, an interval where the function is decreasing, so where it's going down from left to right, and so right here, negative 0.5 to 0.8, so here to here. All right, that graph is going down, and then 2 to positive infinity, the graph is going down. All right, and so we have analyzed this graph by looking at the relative minimum, maximum, and the intervals where it is increasing and decreasing. Now we're looking at radical functions, and so we're looking at a graph of a radical function here. You can see it has some curves, but it looks a little different than the polynomial function. So let's get into some radical functions. For example 3, it says consider the graph of the function f of x is equal to the cube root of x plus 2 minus 4. Which of the following statements is true? It says the domain of the function is from negative 2 to positive infinity, no, the domain would be all real numbers for this graph. It says the range of the function is from negative infinity to positive infinity. We would say yes, because this graph is going to continually go down and up if it keeps going. Alright, so that would be the range. It says the graph has an x-intercept of -2, -4. No, this graph does not have an x-intercept. It is not crossing the x-axis. If we're looking at the fourth one here, it says the graph has a y-intercept of 0.8, and that is correct. So right here. And then last, the graph is decreasing. No, this graph is actually increasing, is going up from left to right. So we have the second and the fourth statements that are true here. The last type of function that we're looking at is a trigonometric function. We remember the sine, cosine, and tangent functions, and so we're going to analyze these graphs a little bit more. For this example here, it says consider the graph of f of x is equal to the sine of x. What is its domain and what are the zeros? And so the domain would take up the space from 0 to 2 pi. So it starts here on our y-axis at 0 and it stops at 2 pi. What are the zeros? Again, zeros are where the graph crosses the x-axis. So the zeros would be at 0, so right here, at pi, here, and at 2 pi. So where that graph crosses the x-axis. Alright, so let's look at an application of a trig function. It says the figure below, or the figure shows graph of T, the temperature in degrees Fahrenheit, over one particular 20-hour period in Santa Elena as a function of time. And for part A, we want to estimate T of 14. So our time is here. So when our time is at 14, and notice this graph is going by 4. So if this is 8, this would be 4. This would have to be 12, and this would have to be 20. So at 14, that would be here. All right, so at 14, it's not quite at 90. So we could say it's about 88 or 89 right here. So that would be our degrees Fahrenheit. For part B, it says if T is equal to 0 and it corresponds to midnight, interpret what T of 14 means in words. And so if 0 is here, and this is at 12 midnight here, okay? So that would mean that this is 4 a.m. This is 8 a.m. So this would be noon, right? And so at 14, if this is noon and we're adding 2 more hours, what would that be? So that would be 2 o'clock here. Okay, if this is noon, 2 more hours would be 2 o'clock. All right, and so the temperature was almost 90 degrees at 2 o'clock in the afternoon. Let's look at C. Estimate the highest temperature during this period from the graph. And so the highest temperature would be right here. All right, so the highest temperature was about 90 degrees, and so we have analyzed this graph here. We're actually analyzing this graph here just a little more, so we have 2 more questions here we want to answer. It says for D, when is the temperature decreasing? And so from this point here, right here to here, it is decreasing. And so that would be between 4 and 8 p.m. And so recall before that if this is noon and this would be 4 a.m., 8 a.m., 12, and then right here this would be 2 o'clock. So at 16 it would be 4 o'clock. And so from 4 p.m. here, so this would be at 8 o'clock. Excuse my handwriting here, I'm trying to write it very small. All right, and so but there's no information after that, and so we could just say it may have continued to decrease, but we're not sure, but we know definitely from 4 p.m. to 8 p.m. And then last, it says if Anaya wants to go for a 2-hour hike and return before the temperature gets over 80 degrees, when should she leave? And so we want to look at the graph and see where it will stop around 80. So here, so we could say the temperature reaches 80 degrees around, where would we be? Around 10 o'clock here. So Anaya should start her hike before 8 a.m. because if she wants to do a 2-hour hike, she will need to start before 8, because around 10 o'clock that temperature is going to reach 80 degrees or more. Okay, we've reached the end of our lesson. I want to thank you for learning with me. If you haven't already, please like, comment, share, subscribe, and click the bell to be notified whenever I post new content. Some related videos are key features of linear, quadratic, and exponential functions, as well as intro into quadratic functions. And so once again, I want to thank you for learning with me.